Okay, so just give me a minute, sir. So
Yes.
now we will begin today's much awaited session on system thinking on AI in AI. So it is our privilege to welcome you, sir, Dr. Sailesh Kumar, sir, Chief Data Scientist at Reliance Jio, Hyderabad. So Dr. Kumar is a renowned leader in the field of AI with the vast experience in
The vast
research and
experience
sorry, with a vast experience in research and innovation and real-world AI deployments, his contribution has significantly advanced how AI is applied at the scale across industries. So today we will learn how the system thinking plays a crucial role in designing the AI solutions and building the solutions or models that are very impactful and holistic in the holistic applications. So, on behalf of Government Engineering College Modasa, I extend a warm welcome to you, sir, and we look forward to the inspiring session from you, sir. So, I will now hand over to you, sir.
Thank you. Thank you for
Sir, thank
inviting
you.
me.
Sir,
Go ahead.
yes, thank you. Thank you, sir, for joining us.
My pleasure. My pleasure, ma'am. It's very nice to be here. It's very nice to see so many people joining on a Saturday evening, and clearly shows a lot of work has gone into organizing this. So let me just see. Can you see my screen now?
Yes, sir.
Yeah. Okay. Great. So this is the talk that I give to a lot of senior people in the industry, and the idea is that I want to kind of talk about three different ideas today, right? So first is I will talk about how companies in the industry have become very data rich companies, right? If you look at a telecom company or a retail company or a manufacturing company or airline company, every company in any domain is a very data rich organization, and they're trying to figure out how to become an AI first organization. So this is the era. The last 20 years we have figured out how to do automation and IT, and now we are trying to figure out how to do AIification of the companies. So this is the journey that every company is going through, and we need to prepare our next set of students to help in that journey, right? So the last 20 years we were focused on teaching our computer science students a lot of coding and architecture and networks and operating systems and all that. But the next 20 years is all about, we have already done that. Now we are data rich organization. How do we become AI first? And nobody understands that because it's not a well defined process. So therefore I give these talks to a lot of senior people across the world on how do you think about your AIification journey and system thinking in AI, right? Now what is happening is a lot of times we come up with AI strategy paper. So India has an AI strategy paper which says, we need to use AI to transform our social sectors, right? Healthcare, agriculture, education. But the strategy paper does not translate into an AI platform, right? Because there is no system thinking. We only have strategy, but we don't have a platform, right? Similarly, a lot of times we tend to think about AI as a collection of use cases. What are the 5 use cases of AI in healthcare, or 20 use cases of AI in agriculture? So when we think like use cases, we don't become operating system mindset, we remain a use case mindset. So this is a very important thing that we'll discuss today in the next 2.5 hours. And let me give an example. So if you think about electricity as a domain, how far has electricity come? Think about it, right? Uh, Today we have very easy way to manufacture electricity, distribute electricity, consume electricity. Very few people are actually involved in all this process. It is almost autonomous. And the reason we are here is not because we have solved the 5 use cases of electricity. So think about it. If somebody said, I'll build a bulb, somebody will build a wire, somebody will build a switch, somebody will build a socket. If I only talked about use cases, will I ever get electricity the way it is today? Not possible, right? So this top-down thinking about putting a grid together, connecting the source to the destinations, and making it, easy to use with a switch and all that, making it safe to use so that nobody gets electrocuted. There are fuses everywhere. See how far electricity has come as a technology. And we want to see AI also coming that far. And to get there, we don't need the bottom up mindset. How do you solve use case one, bulb? How do you solve use case two, fan? But we need a grid mindset. How do you think end to end about producing, consuming, and distributing electricity in a operating system called the electricity grid? So this is the mindset shift that I hope to bring today, because all of us are teaching AI or computer science in a very bottom-up way, right? But I want to bring a top-down thinking into that whole process, right? Okay. So let's talk about AI now. Everybody is excited about AI. Our Prime Minister made a very, very deep comment in the AI Action Summit that happened in France. And he said AI is writing the code for humanity in this century. In the last century, electricity was writing the code for humanity, right? In the last 50 years, internet was writing the code for humanity. You see, so very important innovations have happened in the past. Electricity is one of them, fire was one of them, wheel was one of them, and now an internet was one of them, and now we are in the next era called AI, right? So it's a very important time that all of us should embrace AI, understand AI in many, many ways, not just in one way, and then be able to communicate that knowledge to our students, right? Now, I got into the field of AI because somebody told me that AI is a field where the brain is thinking about the brain, right? No animal thinks about the animal. Dogs don't think about what dogs do, and all that. Only humans think about what humans are. Why are we the way we are? What is intelligence? All these questions only the brain is asking about the brain, essentially. So that is a very profound thing. And therefore, AI is not only one of the most natural subjects because it is about us, but it is also a very impactful subject, and we'll see why, right? So before I get into AI, I just want to talk about what I call the 7 wonders of science, right? So first is we are trying to figure out how the brain works and all that. Then we know quite a bit about how the brain works, right? So we know where is our language center, our vision center, our speech center, our humor center. So we know a lot about our brain, but there's so much more we don't know. So there's a lot we know, there's so much we don't know. Then how the mind works. Again, mind is a great mystery. Our rishis have been trying to think about what is consciousness, what is ego, what is all this awareness. And the modern psychology is now trying to think about that, right? So how the mind works is a very different thing than how the brain works. And I don't know if we can make this interactive. Can we make it interactive where people can also participate? So let me ask.
Yes,
Huh?
sir.
Yeah, so let's ask this question. Why brain and mind are two different words? What is the connection? What is the difference between brain and mind? Anybody? What is your idea of brain versus mind? What is the analogy we can use to define this difference?
Brain is like more mechanical.
Biological. Biological.
Brain is more mechanical.
That,
Correct.
if I
Yes.
may, the brain is a concept about more about biology, and
Uh-huh.
the mind is about psychology.
Mm-hmm. Correct.
I
Okay.
think I think
Uh-huh.
sir, brain is about a physical organ that
Uh-huh.
the human has, and the mind is about the non-physical entity, but it is required because
Correct.
without it, I think there is no value of the human.
Correct. Right? So one way to look at it is you can say brain is the hardware and mind is the software running on the hardware. Right? Does that make sense as a simple analogy? So there are companies like Nvidia, Intel, all these companies are working on the hardware part, right? They're manufacturing the chips, the GPUs, the cloud, all that is the brain that we are creating. And mind is all the rest of it, the chat GPT models, all the machine learning models, all the software, ML ops, all that is the mind, if you right. So now you understand that we can think of AI as two components. The hardware of AI is that part, and the software of AI is the other part. Yeah. Now, other than this, there are many other beautiful wonders of science. We still don't know how evolution works. We know the laws of Darwin, the laws of Lamarck. We know that COVID virus has mutated. We understand the Human Genome Project has been over, but we are still trying to figure out which part of our gene is responsible for diabetes or any of the medical genetic disorders. So there's a lot we know, there's a lot we don't know, right, in evolution. Similarly, the quantum world is a great mystery. There's a lot we know about the quantum world, but there's a lot of mystery around it, right? And it's keep evolving. So quarks and atoms and protons and all of that. Then there's a lot of mystery around the planet also. We think we understand the planet, but you can still not predict the next earthquake or the next volcanic eruption or the next heat wave. So there's a lot of research going on in how the planet works. Then how the universe works is again a great mystery. We thought Earth was the center of the universe. Now we realize it's just a speck of dust in a middle of nowhere. And there is not one universe but multiverse and all that, right? So we are growing our knowledge of what the universe is. And finally, all this is useless if we don't understand what life is and how life works, right? And the fields of biology and all the relevant fields are trying to figure out what life is. And if I think about it, we understand so much about life, right? But we still cannot create an artificial life. We still cannot create an artificial blood, or we cannot do artificial photosynthesis. So while we have studied photosynthesis, blood, organs, life, cells throughout our lives, we still can't produce them, right? We need natural processes to produce them. So these are what I call the great mysteries of science. And we are interested in the brain and the mind part of it in the field of AI. Yeah. Now, let me ask another question. This is from the movie Three Idiots. Remember the Three Idiot question, what is a machine? So let me ask this question, and I want your general feedback on what is technology to you? What does it do for us? Tell me.
I think, sir, it is an applications of any knowledge, I mean scientific knowledge, which can help us to solve any issues.
Very good. Okay. So application of science is technology. Very nice. What else?
Like sometimes it can be a tool systems, or sometimes it can be the methods.
Very nice. Yes. Yes. Okay. What else? Any other thoughts? What does it do for mankind? What are some of the things it does when we do technology?
Sir, it makes our life very simple.
Mhm. Okay. Okay. What else? Anybody else? Yeah.
Participants can also answer. They
Yeah.
can
Yeah.
unmute themselves.
Yeah. Yeah. Please. Anybody? What does technology bring? So let's take an example. So back in the day, when we didn't have the plumbing, for example, in the cities, we would have to go to the nearest river and bring water from there. And we used to carry the water in the pots. And the pot was the early, technology mankind created. Pots were used to bring water, store water, cook food, and all that. And then the new technology came. The pipes came, plumbing came, and now we don't have to go to this. And so convenience is one thing that happened, is one thing that technology does, right? Another thing it does is it brings scale. So if you think about today, we can manufacture cars at scale, iPhones at scale, right? So scale is the next thing that technology brings. Another thing it brings is efficiency, right? With a lot less energy and human resource, we can do a lot more, right? So all the manufacturing and all of that is very efficient compared to how it would have happened manually, right? So we understand that technology brings scale, efficiency, consistency, convenience to human society. But I'm going to give you a new definition of technology, which I really like. And this definition says that a technology is a way that humans have extended themselves into machines. So think about it. How humans have extended themselves to machines is also technology. So if we cannot lift heavy things, we have created the lever and the crane. If we cannot run very fast, we have created the wheel and the cars. If we cannot fly, we have created the aeroplanes. If we cannot speak loudly, we have created microphones. If we cannot talk to each other across cities, we have created Zoom calls, right? So these are all technologies which are nothing but an extension of human capacity into machines. Now, the next question is, okay, we have extended our arms and legs and eyes and ears into machines. What else is so unique about us that we would also like to extend to machines? Tell me. What makes human civilization so unique compared to all other millions and millions of life forms out there that we would also like to extend to machines? Anybody?
Extending the machines means, sir, I mean, upgrading the hardware component or
No,
any
no, no.
automation kind of
Extending,
thing.
what capability do we have? So we have an ability to walk. How we have extended to machine is by creating cars and vehicles, right? So what is the other capability we have that we would also like to extend to machines?
Sir, I would like to say that we also like to extend our intelligence and the
Right.
way we perceive world and how we feel emotions and everything. So I guess
Correct.
we also want to expand our plasticity of brain to, I guess, technology and machines,
Very
the way
nice.
we function
Right. So see why we
cognitively.
that, yeah, very important. And why, so let's talk about this, right? So we have extended our arms and eyes and limbs and everything else into machines, right? The telescopes and this and that. Now this is the era in which we are extending our intelligence into machines. Now think about it. Why is it so important? Every time we extended our arms into machines, what happened? The human civilization changed suddenly, right? We were able to create buildings and cranes and all of that, right? We extended our legs into machines, we invented the wheel, and then everything else happened after that. Suddenly the human civilization changed completely. We are able to create larger and larger cities and move across the planet because we have wheels and aeroplanes, right? So every time we have extended one aspect of ourselves into machines, we have seen a non-linear transformation in the human civilization. And now we are talking about the most intelligent, most important, most precious gift that we have, our intelligence into machines. What would that do is something we can't even imagine today, right? So let me now tell you why this is a very big deal. We all should feel this importance of why AI is a big deal. We have to feel this, right? So let me take an example. So let's say if I'm sick, I want to go to a doctor. I would rather see a senior doctor and not a junior doctor, right? And why is that? Why we want to see a senior doctor? Anybody? Because
Experience,
experience.
experience,
So let's remember this.
expertise.
Yeah, expertise and experience. Let's remember that keyword, experience now, right? Now think about a human doctor who can see 30 patients a day, and they can see probably 1 lakh patients in their lifetime. And they are gaining experience every year on year, and they're becoming a better doctor because of that experience, right? Now, a single human in a lifetime can see, let's say, 1 lakh patients, right? Now imagine an AI doctor, and I'm going to show you what I mean by that. An AI doctor, let's say, can see 1 million patients every hour on the cloud, right? Millions of people can do search, millions of people can do Netflix. Why not millions of people can see a AI doctor, which is available to everybody? And now that AI doctor is collecting 1 million data points every day, every hour, and learning from that. Do you see the difference that when we scale human intelligence of a doctor into an AI system, suddenly the ability to gain experience is now million times more, and now it can learn so much better and become a much better doctor than a human doctor can become in a whole lifetime, right? So let me give another example. A lot of us do research, so we understand how research is happening today, right? So we read some papers, the right papers, we remember them, we connect the right dots, and then some insight will come, and then we pursue that area of research, right? This is how science has been progressing for the last thousands of years. Now see how serendipitous that process is. By chance, somebody read the right papers. By chance, somebody connected the right dots. By chance, they came up with a good insight. So far, the last 1,000 years, scientific research was serendipitous in nature. It was not deliberate, it was not exhaustive, it was by chance happening, right? Now, imagine what will happen in the post-AI era. To the most important pursuit of mankind, which is scientific research, what will happen to that in the new era is that we are going to now not have to worry about what a limitation of a human mind is. But all data is now there on the cloud. All of that is read. Nobody will forget that. AI does not forget anything. AI will connect all the dots, and AI will continue to do deep reasoning on exhaustively all knowledge of mankind. Right? While we are sleeping, AI is still doing research on that. So now what will happen? You will see the next going forward, we are going to see a lot of Nobel Prizes coming because AI was a co-inventor and it was going to invent things every minute. You will see a beautiful invention coming out of AI once we reach that level of intelligence, right? So that is why AI is such a big deal. It is going to transform human society in a very, very big way, and therefore this is a great moment for all of us to be part of this, right? So there's a beautiful convergence of technologies happening. AI is not the only technology. AI has been around since the 70s. But what has happened in the last 50 years? Internet came, devices came, telecom came, connectivity came, IoT came, cloud came. Now, because of all this together with AI is much more magical than none of them and only AI. So it's the convergence that is creating the magic. So if you think about how Swiggy, Zomato works, or Ola, Uber works, or YouTube works, it will not work if all these technologies were not present. So this is something that our students have to appreciate, that we are living in a world of technologies, knowing all of them to some degree, and AI to a deeper degree will really help us create and reimagine the future. Reimagine is the new skill. Coding is not the new skill. AI is not the new skill. Reimagining the future with technology is the new skill. And that is what we try to teach our students. So, for example, what does reimagine mean? And I'll show you many examples of that as we go along. So let's take an example of how do we buy a chair today. So today, what do we do? If you have to buy a chair, you go to a store, you go online, you try some chair here and there, and then you decide to buy a chair. Now let me reimagine what buying a chair actually means. So let's say you go to ChatGPT and say, I want to buy a chair. It'll ask you some questions like, what is your body weight, body type, height, this and that, ergonomics and all that. And it'll design a perfect chair just for you. Now what will happen? You want to experience that chair. So now imagine we have an AR VR system where you can actually experience a chair, the chair that AI has designed. So now you have AR VR, you have ChatGPT, and now you've liked the chair. What do you do now? There is no print, there is no buy button because that chair does not exist. But there is a print button where you can print the chair in a 3D printer nearby or at your home. So you see, what have I done just now? I have reimagined retail, buying a chair or a furniture, to a new problem, which is design what you want, try it using AR VR, and then print using 3D printer. So who is going to be able to do this kind of reimagination is the person who understands these three technologies. That will be the new Steve Jobs or the Elon Musk of India, right? So we need to create people who can imagine these kind of capabilities, right? And we'll do that. Now, among all these technologies, AI is considered the most important. And in the last 20 years, we have only solved, some search engine problems, some recommendation problems, some marketing problem, some ads problem. So we have only focused on commercial use cases of AI in the last few years, few decades. And now onwards, we are going to solve the real social problems with AI, right? So today our students are struggling, our patients are struggling, no access to doctor, our farmers are struggling, no access to proper advisory. What should we do? We should AIfy all these systems. So the next reason why our students are learning AI is not to get a job in JP Morgan or do some stock market, but really to transform society with intelligence, right? So we need to help them think about what are the real problems to be solved, and how do we think differently, systems way in AI to be able to solve those problems, right? So that's what we'll talk about today. All right. So let me now talk about the 5 building blocks of intelligence. So let me ask this question now. What is intelligence? Turn on. Yeah. Tell me. So what is intelligence? Any thoughts? Are you able to hear me? Yeah.
Yes, sir, you are audible. I think
Okay.
it's an ability to learn, understand, and apply some knowledge,
Mhm,
adapt new situation,
mhm. Very
or
nice.
think.
Right. Right. Okay. Very good. Anybody else?
Any
Yes,
Our
sir.
audience,
participants?
Yes.
Sir,
participants?
I would like to say
Yeah.
that when it comes to intelligence, it is about the whole process of acquiring knowledge,
Mhm,
somewhere applying it, and involving the subjectivity of our own cognitive capabilities into
mhm,
various fields. So there could be many types of intelligences, like emotional intelligence, charismatic intelligence. There could be many. So it is all about our experiences and how we perceive things and how we implement it with the analytical approach,
mhm.
and that's in the shell.
Very nice. Very nice. Good. Very nice. Anybody wants to add? So we
Yes,
have,
sir.
yes, please go ahead.
It is to adapt the new environment,
Mhm,
uh, solve the critical problems.
mhm, mhm. Critical
That's it.
problems, problem solving and adaptation. Very nice. Okay. Anything else? There is one more form of intelligence that I have not heard about here. So what kind of intelligence do our, let's say, chess players have or mathematicians have? Is one kind of intelligence, right? They are able to think about the problem and problem solving, and that is one kind of an intelligence, right? What about the other group of people, like the musicians, the artists, the J.K. Rowlings of the world, the writers? What kind of intelligence they have? What do we call that? Artists, poets, inventors?
Sir,
Any?
creative intelligence.
Correct. Creativity. Creativity is considered the highest form of intelligence, right? So here are the 5 building blocks of intelligence that I have thought about. So the first one is what I call the ability to learn. So we talked about the ability to learn. We all are in the learning environment. We ourselves have learned so many things in life. Every day we are learning new things. So we'll talk about what is learning from a machine learning point of view. Second, we talked about understanding, right? What is understanding? So when our eyes are seeing something, our brain is understanding. When your ears are listening to something, our brain is understanding, right? When a doctor is looking at an ECG report, he is understanding. So what is understanding? We'll talk about that. The third principle we talked about is thinking, the ability to think. And thinking is really solving a sequential problem and all that. And the fourth we talked about is creativity. And why is today, creativity happened in the last 5 years with ChatGPT and all such technologies. Suddenly the world is waking up to AI. And AI was there before also, right? Learning, understanding, thinking was already there. Suddenly creativity created all the buzz. And it became such a fad. Everybody's using this, creating Ghibli images, writing poems, doing homeworks and all that, right? Now, the reason creativity was such a big milestone is because creativity completes an intelligent system. Without creativity, intelligence was incomplete. So let me give you an example. So if let's say you are learning English or any language, you can understand English, but you cannot write English, right? So we have a reading comprehension, but we also have a composition, right? We want to write an essay or a letter or something. Without the ability to create language, only understanding language is not enough, right? Similarly, if you can see the world but cannot draw, if you can hear the world but cannot speak, if we listen to the song but cannot sing, that the second aspect is missing, creativity, right? And therefore we need creativity to complete intelligence. Now this is so profound. If I give you this example, you might know this. When a baby is making a cooing sound, right, we call it cooing sound, they will say that. Why do they do that? Is because their brain is telling their vocal cord to make a certain sound. Their ears are hearing that sound. So creativity, vocal cord, understanding, ears, and now they are comparing the sound they are supposed to create and the sound they are hearing, and they compare the two sounds and see whether they have to fine tune the vocal cord or fine tune the hearing. This process is critical, and that is why singers listen to themselves a lot very carefully with a headphone, because they are fine tuning their vocal cords. You see how creativity and understanding kind of go together, right? Okay, so we are here now. Human race has created AI which can do all these four things, and now we are worried about the fifth stage of intelligence, which is what we call sentience. So when we are growing up, when our students are here in college, uh, we notice that sometimes, they have their mind of their own, right? They want to do their own thing. They don't want to study. They want to go hang out with their friends, right? They'll question everything. Why should I do this? I don't want this. I don't like this. So this I has developed in all of us at a certain age after we have developed the first four qualities. That is what I call the fifth stage of intelligence, becoming sentient of who we are, our ego, our self-awareness. Now, why I'm telling you all this is, I want you to think that, let's say, human race is the parent and AI is the child, right? Human race has provided all the algorithms, all the compute, all the data, all the energy, and now we have trained AI and becoming better and better over time. So now we are there, right? And now the question is, what if AI becomes self-aware someday? And this is one of the discussions that is happening in the corridors of AI, where people are now worried that if we don't put the right guidelines and regulations, AI can actually destroy humanity instead of redeeming humanity, right? Which is true for any teenager. A teenager grows and they can destroy themselves or redeem themselves depending on the choices they make, right? So this is a critical stage for AI and mankind. AI is now crossing from fourth stage of creativity to the fifth stage, and we don't know what the future is going to look like. Yeah. So it's a nice to have stage, but it's also one of those things we don't know. So let's talk about these four things, so we understand them at an intuitive level. So what is learning? So if I show you this picture, you'll say, this is a letter A. Now we take this for granted that I can recognize a letter A on this slide. This is completely magical. This is so amazing that we have never seen these A's before, and yet we can say that this is an A. And the reason we can do it is because we don't remember and memorize the data we have seen so far in our life, right? All the A's, all the cars, all the cats, all the auto rickshaws. We don't remember all the data, but we build a model for everything. So our brain consumes the data. It doesn't remember the data. It builds the models and it updates the models. So now in our brain, we have millions of models, some for letters, words, places, vehicles, everything, right? Relationships. So we have a model for everything, and we use those models. And if some input like this comes, all the other million minus one models are silent. Only one model is saying this is an A. And we have never seen this A before. And that is magical to me, right? If you just pause and think about it, how does the brain do it? Why does the brain do it? So let's take about the why of this. This is very important to understand, that why did nature chose our brain to become a generalization system, not a memorization system, right? So we are not an SQL query that is matching this pattern to all the patterns I have ever seen. We don't do that. we are a fuzzy matching or a similarity engine, right? I have seen something similar to this, therefore it must be an A, right? Now, why is that important and critical? So think about it. If you are in an evolutionary framework, predator-prey scenario, tiger and deer, in their lifetime, they will never ever experience exactly the same thing ever again, right? In our lifetime, we will never ever experience exactly the same thing ever again. The same commute will be slightly different. It will be similar, but not same. Therefore, in the great mercy, nature decided that we want to make brain as a similarity engine that says, oh, yesterday when I was here, the sound was coming from the other side, but there was a tiger. Today, the sound is coming from the other side. It looks similar. Let me run. And that led to survival. So you see how learning and generalization is actually the ability to survive depends on the ability to generalize, right? Because we will never experience the same thing again. Now, what does our brain do? If you think about every day, what happens? So there is a reality out there, right? So there is some reality. None of us know what that reality is. There is some reality out there. Now, all of us have sampled a taste of that reality, depending on which place you grew, what was your education background, parents, culture, religion, all of that. We have sampled some subset of that reality, right? And that is the data we have seen in our lifetime so far. And now what have we done? We have done two things with that data. We have either discovered a new model. Oh, let's say you've never seen a llama animal before. First time you see a llama, you might say, oh, this looks like a hybrid of a giraffe and a camel. What is it? And then somebody says, this is a llama. Then you say, oh, so let me add one more model to my brain. So this is how we keep adding more and more models to our brain as we discover new and new concepts in our life. And the second thing we do is we refine existing models throughout our life. So let's say you have seen only certain types of chair. First time you go to IKEA and you see a new type of chair or a chair with wheels. And then what happens to your model of a chair? You already have a chair model, but now it is refined to say, oh, chairs can also have wheels, right? So we do only two things throughout our life. We either discover new models and keep adding them, or we refine existing models and they get refined. So this is the model, and when we generalize from the model, that is the reality we have in our brain. So AI is all about reverse engineering the reality out there via the data and the models to a reality that an autonomous vehicle understands or a chat GPT understands, right? They don't understand reality. They understand a model of reality, which is not reality itself, right? This is true for us. This is true for all AI systems. And what do we do with these models? So every day we wake up, imagine you are a 5-year-old or a 10-year-old or a 20-year-old. Every day when we wake up, our models are better and better, improving. And because that day when I wake up, I use the current set of models to lead my daily life of that day. At the same time, I collect all the data of that day in my right brain. When I sleep over it, that data, along with the current models, again does its thing. And next day, I wake up with a slightly better set of models, right? And this cycle goes on every day. And that's why we have the inference cycle and a training cycle going on every day in our mind throughout our life, right? So we are a mini batch training system on a daily basis, right? See, when I teach my students AI in this way, right, they really understand it. Because if I teach them linear regression or something out there, they will not understand AI, right? But if we teach them about AI as your own thing, this is how we learn, this is how our brain works, then they will understand AI in a very natural fashion, right? Now, what is understanding? So now if I show you these two pictures, right, you'll say, oh, there's nothing to it. These are just two parallel lines. But now what happened to the lines, right? So one line is different, the other line is different. Why? So what happened? Tell me. What changed between this and this? What is the word? Hello, am I there?
Yes, sir.
So what changed between this and this is the context, right? The context gave meaning to the content, the line, right? So this is the principle of understanding. We don't understand the word by itself. If somebody asks you, what is the meaning of the word cricket? You cannot tell unless you know the context. Are you talking about biology or sports, right? So we always have a meaning associated based on the context. So similarly, in the vision world I showed you, in the language world, if I see this bottom example, I was right to avoid a suit against apple. Man in suit on my right was drinking apple juice. Now, what is your brain doing now? Is it is reconciling what meaning of the part makes sense with the whole, meaning of the whole. And what meaning of the whole makes sense with the meaning of the part. So we go up and down the hierarchy very quickly, and our brain settles down and says, yes, now everything makes sense. If I assign this meaning to right, this meaning to suit, this meaning to apple, then it all makes sense, right? Otherwise, it didn't make sense. So this principle is called understanding. Our brain is very good at speech understanding, language understanding, and all that, because our brain is able to go up and down and say what is the meaning of a pixel, what is the meaning of an image, going back to what is the meaning of a pixel. So it goes up and down the hierarchy, and this principle is what we call the cardinal principle of understanding, which is you shall know a word by the company it keeps. And same thing applies to images. You shall know a pixel by the company it keeps, right? All the CNN and all the networks we see, right? Similarly, speech processing. Similarly, symptoms. If you go to a doctor and just say, I had fever, can you diagnose me? He cannot diagnose. He wants to know the whole context. What are the other symptoms? Only then he can tell, right? Gene sequences, cancer research, and all that, right? So this is the principle behind all language processing, vision, speech, and all that. Okay? And humans have developed a very sophisticated understanding layer. So now we are able to understand all the five senses, because not because the brain can understand them. The brain does not know how to understand language. Well, language it has, but smell and touch and taste and hearing, it doesn't know how to do that. It has created systems called, the vision system, the olfactory system, the auditory system, and all that, to understand the data coming in that format. And now we are able to process that in the brain. Yeah. So this is the beginning of the understanding layer, right? What is thinking? Thinking is one of the most sophisticated and the least used paradigms in machine learning AI right now. Uh, so let's see what it is, right? So if I have to do Google Maps kind of a thing, I have a start state, I have an end state, and then I have a current state. And the state is defined by the lat long and the maps on the map. Now, what is our brain doing? What is Google Maps doing? Is it is saying in the current state, what are the feasible actions, possible actions, and among the feasible action, which is the optimal action. So these three things that we do all the time, right? We are in a current state. We define the feasible actions, possible actions in the current state, and then we pick the best action among the feasible actions. And then once we do that, execute, we go to the next state, which becomes the current state. And this process is called thinking. And I'm showing you an example here, but let's see some more examples, right? So once you take one of the actions, you go to the next state and you repeat this exercise. And how long will you repeat this exercise? Till you reach the end state. Now, this framework, let me show some more examples. So let's say I have a mathematical expression to solve. This is also a state now. So in the Google Maps, lat long is the state. In this world, an expression is the state, and I want to simplify. So now what is our brain doing at this time? Is it is saying, what patterns can I match? And it will say, oh, this looks like a plus b whole square, a minus b whole square. If I apply that, I will get a new state. So you see state, feasible action, optimal action in this case, and then we took the action, we got to the next state. Then again we take action, then again we keep going till we are satisfied. Now, is there another way to solve this problem? Like Google Maps can give you multiple solutions, right? Is there any other way to solve this problem? Anybody? Can we apply any other formula? No?
Sir,
Yeah?
we can assume values for x and y and then we can calculate.
No, it's an algebra problem. There's no value for x and y. But is there any other formula like I showed a plus b whole square, a minus b whole square? Is there any other way to look at this problem? Is there any other feasible action we can do?
No, sir.
No, no. So can I apply a square minus b square here? See? Can I not apply a square minus b square? So that is also a feasible action, right? Because we still see that pattern and we can continue and solve the problem, right? We get the same answer. So like in Google Maps, math solving is also a sequence of steps. There is state, action, state, action, state, action, right? So this is also reasoning. Another example of reasoning. So let's say I'm playing tic-tac-toe. Our brain is now thinking of what are my feasible actions in the current board position. And from there, what are my optimal actions based on all the games I have played. And then I take that, I move on to the next state, right? And we keep doing and keep doing, right? So again, this framework is very powerful. Now let me apply this to healthcare, for example. What is the state of health of a person? So if you are taking regular tests and you can measure what is my kidney health, what is my cardiac health, what is my mental health, can I not create a state of the health of a person? And now what are the possible actions? You go to a doctor, he will see all this and say your cholesterol is high, your BP is high, your whatever is low, whatever it is, and he'll now take actions. He'll say exercise more, eat better, take these multivitamins, go for a surgery. So these are the actions in medical terms, right? Similarly, if I think about retail, right, a lot of data is coming in retail. Can I create a state of a customer and say he's a loyal customer? He likes to shop only in the Friday evenings or Saturday mornings. He likes to buy only these category of products. He likes these brands. So what have I done? I've created the state of a customer. And now what are the actions in retail? Actions could be, how do I lay out my store? What coupon should I send to which customer? How should I price my product? How much inventory should I add for each product in my store? So these are my possible actions. So you understand that everywhere, whether in agriculture, health, retail, anywhere, I can apply the thinking framework, right? So really most important framework in AI is the thinking framework. It's not ChatGPT. It is thinking framework, and we should be able to create a lot of thinking systems, right? Fourth layer of intelligence is creativity, where we are saying, let's say one example, first line is to ChatGPT, I was walking in an empty parking lot, and we said, create a story with that first line, and the last line is, I safely returned home, create a story. So then it created this story. I saw a suspicious man walking towards me. I turned around and ran the other way. Man started running after me. Ran as fast as I could. Man couldn't catch me. I safely returned. So we understand that ChatGPT is now able to create fantastic stories, fantastic poems, fantastic reports or PPTs, whatever you are using it for. And the question is not that can it do it or not. We understand it can do it. The real question now we are asking is, does it really understand what's a parking lot? So tell me, how do we as humans understand what's a parking lot? Or run as fast as I could? How do we understand this idea? Through experience, right? So we have been to parking lots, we have seen suspicious people. So we understand the world through experience, not by reading millions of documents. So you see where AI is today. AI is in a very primitive state, especially Gen AI, where it does not understand the world the way humans understand. It only says token this followed by token this followed by token this should be followed by next token. And through that exercise and a lot of compute, lot of data, lot of energy, and lot of algorithmic improvements, it is finally able to do this kind of thing. But we are not sure whether this is the right approach to AI. This is not how humans do it. That doesn't mean this is how machines should not do it. That doesn't mean that at all. But still, this is a non-sustainable process, right? And all that. Similarly, we can now generate code, and we can see that code can be generated. Vibe coding is here. We can generate images. So we can say, hey, give me Pentagon red clock. If it doesn't exist, it will give me. If it exists, it will retrieve. So now we're going to see retrieval and generation working together, right? We've been studying information retrieval for the last 20 years, thanks to Google and all that. Now we are going to study generation for the next 20 years, and improvements will come. So if I say cubicle red porcupine, there is no image that exists, but it can still generate that. Yeah? We can also see avatars now coming up. So news article, news reading can be done by a avatar, like a digital person, not a real person. And we have done Ghibli images, and all this is possible now. So you can configure your avatar for reading the news for you, and it can be done now, right? There are many dangers of AI coming up, right? Our Aadhaar card and this card, that card, ID creation is now becoming easy. So how do we prevent that? So we need to think about those things. Music generation is possible. I'll just play a video music for you. Can you hear? Were you able to hear that? Hello? Hello? Were you able to hear that?
Yes.
Okay. So
Yes,
now
sir.
music can be created by AI, right? And this was a reasonable music. Now imagine you are going home, you are stressed out, you want a relaxing thing, and you say, hey, Suno.ai is a website. You can go and say, hey, I have this mood. I like Jagjit Singh. Can you create a ghazal and play it in his voice and his style, right? So you don't have to find a ghazal and play it. You can create it on the fly and play it. So that is the future of music, for example. Uh, Similarly, now let's play this video and see what you think of that.
I am not Morgan Freeman. What you see is not real.
Sorry, it's not, the facial expression was not coming. Let me start.
I am not Morgan Freeman. What you see is not real. Well, at least in contemporary terms, it is not. What if I were to tell you that I am not even a human being? Would you believe me? What is your perception of reality? Is it the ability to capture, process, and make sense of the information our senses receive? If you can see, hear, taste, or smell something, does that make it real? Or is it simply the ability to feel? I would like to welcome you to the era of synthetic reality. Now, what do you see? I am not more.
So this video is very interesting. There are two parts to this, right? First is to say that, oh, AI has now reached a level of this much of reality that we can create a video like this. But second thing, what he's saying is even more interesting, right? We talked about if you can smell, taste something, does that make it real? And that is now opening up new discussions, right? Same thing that our rishis have been talking about. What is reality? What is Maya and all that? So think about it. When we are in a deep nightmare in our sleep, we know that this is not real, but during that period, it feels very real, right? We feel fear. How do we feel? And that is what he's talking about. And you can see where now AI is going in terms of what is reality we are questioning, and all of that, right? So these are very interesting times for philosophers and AI experts to think about this. So the question is, are we there yet, right? Are we Have we achieved what we were supposed to achieve? And all these great fathers of AI are still not sure whether we are there or not. There is a long way to go. Gen AI is going to continue to improve. It will become smaller and better and faster and non-hallucinating. Many other algorithms are there that need to be developed, and AI will continue to evolve. Yeah. And the last stage, self-awareness, is what we are all worried about. This is, a debate that is going on in the world now. What will happen if AI becomes self-aware, right? So that is the other debate. I don't want to play this video, but now let me pause and see if there's a question, so I can continue to the next part. Anybody has any questions? No? Okay. So now let's talk about a universal architecture. So we talked about the building blocks, the atoms. Now let's talk about the molecule. How does it work together, right? Is there a simple way to explain AI to anybody? So here is my, after 20 years of doing this across domains, across industry sectors, this is a very simple architecture of AI. All intelligent systems are what I call stimulus response learning systems. So the first thing that happens is stimulus, right? Like our eyes are receiving data, our medical sensors are receiving data, right? So let's say a doctor is looking at a patient, and the reports, the blood reports and all that, plus the symptom is the stimulus data, right? Similarly, in the world of, let's say, retail, all the purchases you have made in the past is the stimulus data for Amazon. What do we do with that information, right? So what does a doctor do with all the stimulus data? What is their main job? A doctor really converts all that, right? Blood reports, all the reports and your stimulus data into the state of your health. He says you have dengue, you have malaria, the diagnosis. So diagnosis is the state. So we understand data is the stimulus, raw data, and what you come up with is the state and say this is the problem. Now, similarly in retail, what is stimulus data is your purchase history, your search history, all that is your stimulus data. What is the state? The state is understanding of the customer, right? What brands he likes, what color he likes, what category of products he buys. So how do I define the state of a customer? How do I define the state of a store, for example, in retail, right? What are the products I'm selling? What is the inventory of every product? Is the state of the store, for example, right? Footfalls, things like that, revenue, profitability. So I can define the state of the store, state of a customer, all of that, right? Now, is the state enough? So if you go to a doctor and he says, yes, I have diagnosed you, you have malaria, please go. Is that enough? So that is not enough. So the second part of AI is converting state to action. So we talked about thinking, and then what happens? The action gets executed, and now what happens? You get a response. So the patient may have gotten well or not is a response. You sent a coupon based on your understanding of a customer. Did he click on it or not is a response, right? So we understand all intelligent systems are a stimulus, state, action, response systems, right? Now, this diagram I could have implemented with IT also. I could have used, if then else statements to say, if these are the symptoms, this is the disease. If this is the disease, these are the medicines. I could have coded up the state and the action models. This is still not an AI system. What makes it an AI system is the feedback. And remember, we talked about the doctor and an experienced doctor versus a regular doctor. So if you're a regular doctor and I have programmed you with a certain set of rules, and you're continuously applying the same set of rules without learning anything new, you are not gaining experience. So the true difference between AI and IT is that IT is a static system programmed by somebody. AI is a dynamic system that keeps improving with feedback. And now there are only two types of AI in the world. One group of AI models convert stimulus data to state. Like if you're saying something to Alexa, Siri, speech understanding, right? Vision understanding, profiling of a customer, segmenting a customer, forecasting the demand. So this is just understanding the world around us. This is one type of AI, right? And we also have that. We have 5 senses, the stimulus data, and we understand the world around us, the state. And then we act on that state because we have some goals in life. So the second type of AI is all about taking action once you understand the state. So we decouple this, and this is how you can define all industries in a single slide, right? Okay, so now let's take a very simple example. The favorite pastime of India, crossing the road. So what is the stimulus now? The stimulus is we are looking at the road, we are looking at the cars, how far they are, how fast they are coming. So our brain is continuously monitoring the road on one side. So that is the stimulus. What is the state our brain is doing? It is now creating a state called, is it safe to cross or not safe to cross? So safety is the state. Based on the estimation of how far and how fast, our brain has made a calculation that it is safe to cross or not safe to cross. Then we take the action. The brain tells the legs to go forward or stop, and that is the action. And what is the feedback or the metric? That we safely cross the road, right? So we understand this process is very universal. So now let me show this process in Ola Uber. How does this work, right? So what is the stimulus in Ola Uber? So if I think about the different apps we have a customer app, which is generating a lot of data, right? Which customer from what location at what time is trying to book a cab to what end destination. So I'm collecting all that data. Similarly, I have a driver app that is collecting all the driver related data, right? Cancellations and all that. I have third-party data like Map My India, where I'm getting all the map of the country. Then I have the internet data that is telling me that there is a stadium event going on. There's going to be a big rally by somebody. So traffic jams and traffic, car demands will change. And then I have weather sensor because all that will also affect my demand of cabs. So you see the raw data that belongs to your own apps is your data. And also third party data is also public data is also stimulus data. So we look at all that. What do we do with it? We now build models. We say, define a customer, right? So we say he's a loyal customer. He is a commute customer. He's a weekend customer, or he's a mini or a shared ride customer, right? So we define customers, we define drivers. These are loyal drivers. They stay with us 8 hours a day. Or this driver comes and goes depending on where he gets more money. So he's a opportunistic driver, right? What time he logs in, where does he live? So we build models for that. Then we build models for forecasting demand. How many cabs of what type do I need in this location, that location? Then I build supply models, event models, and all that. So now I've defined the state of the city, state of the cab, state of the customer, state of the driver, state of the location. So these are my state models. Now what do I do with them? I have actions to drive. Then I say, okay, what incentives am I giving? What offers am I giving? How am I moving the cars around? How am I pricing my rides? Right? Who am I allocating the cab and not allocating the cab when I don't have enough cabs? How do I define that? Now, stimulus to state, state to action is done. Once you take the actions, at the end of the day, the same stimulus data will help you calculate the metrics and say what were the cancellation rates, what was the fulfillment rate in Ola, what was the revenue, what was the profitability. Now, this is still an IT system. This has still not become an AI system. When does it become an AI system? When we add a feedback and say, maybe I didn't estimate the demand of cabs correctly. So I had less cabs and more demand. Or maybe I didn't do the actions correctly. So my estimates were correct, but I didn't move enough cabs to the high demand areas. So my action was not correct. So we basically learned the two models, and this is a continuously learning system. That is what makes Ola Uber a AI company. It's not just a taxi company, right? Search engines are not just search engines, they are AI companies, right? YouTube is not just a video company, it's an AI company. What makes them AI company is this ability to learn from feedback and continuously improve their state models and their action models is what makes them AI companies, right? So if you understand this principle at a top-down system level, then AI becomes very, very simple. Now you can teach clustering all day long, Why? Because clustering is a part of, customer segmentation, a stimulus to state model. You can teach them reinforcement learning because it's part of the state to action model, right? So without this context setting, when we suddenly start teaching our students, do this, do that, then they get very confused, right? And so this context setting is very important. I'm very happy to share these slides with you. You can use them, set the context before we get into the details of the course, right? Okay. So now what I'll do is first I'll go to the third part, next part, and then I'll come back to this if we have time. So now I'll talk about, so we understood what is AI, how does it work at a high level, right? We know that all the algorithms that you have ever seen in AI, regression, supervised, unsupervised, this, that, fall into that architecture, and we understand that. Now we'll talk about the next 20 years, where are we going, and how to do system thinking in AI, right? So this is the main theme now. So let's spend the next 1 hour on this. All right. So let me ask you this question. What makes a great product? So we use products every day in our daily life. What makes a great product?
Friendly usage, and the easy to use property.
Correct.
And I think the most important one is it should work effectively.
Correct. So we're going to define what is effective, right? So what does effectively mean in Google search, for example, or Google Maps, or ChatGPT, or Ola is different, right? What is effectiveness, right? Good. So any other thoughts? Any other products? Give me some example products that we really cannot live without. And I'm not
So nowadays with yes, so
about...
nowadays without mobile we cannot live.
Correct, right? So mobile used to be just a phone back in the day. Now it is everything, right? It is your payment system. It is your photography system. It is your email checking system. So mobile has become everything, right? It's a great product. It serves a lot of needs in one place, and slowly it is becoming more and more intelligent also. Yes. Any other products?
Participants can also answer.
Yeah, I think today.
Yes, sir.
Yes,
Yes,
please
sir.
go ahead.
If it match the requirement of the client,
Mm-hmm. Mm-hmm. Correct.
so that we can say that it is a great product for
That's
that particular person.
yeah. So, that's a very beautiful general definition of a great product. But matching the requirement alone is not enough. The word effectiveness was used before, right? It matches the requirement, meets the requirement effectively, right? That is what makes a great product. So here are my 5 I's of a great product. So let's start with the first one. So the first one is what I call the infrastructure. Infrastructure means the ability to scale a product. So let me classify products into 3 categories. Physical products like phones, TVs, pods, jewelry, clothing, vehicles. So these are all what we call physical products. How have we scaled them? We have scaled them because we have learned the art of mass manufacturing, right? Thanks to industrial revolutions in the past, we can mass manufacture cars and clothes and all of that. So scaling means mass production and supply chain distribution, and the whole thing is scaling in a physical product. How about a purely digital product? So YouTube, Instagram, WhatsApp, LinkedIn, Facebook, ChatGPT, these are all purely digital products, right? There's no physical part to it. They're purely digital products. And because they're digital products, they scale because of the cloud. And all we do is keep adding more hardware and software to the cloud, and these products can keep scaling, right? So scaling or infrastructure means different things in physical and digital products. Now, what is the third category of products? Ola, Uber, for example, or Swiggy, Zomato, or Amazon, Flipkart. What kind of products are they? Are they purely physical products? Are they purely digital products? No, right? They are a hybrid product. They are what we call a phygital products. So now the world is moving into the phygital products. And what does infrastructure mean in a Ola Uber case? There is a digital infrastructure, there is a physical infrastructure. The digital infrastructure can scale with cloud infinitely, but the physical infrastructure cannot scale infinitely, right? Because you cannot have infinite cars, you cannot have infinite delivery guys in Swiggy, Zomato, you cannot have infinite uh, products on the shelf in the retail stores and so on, right? So we understand scale means different things in the physical world and in a digital world. And a digital physical product, scale is limited by the physical part of it, not the digital part. Okay. The second I that somebody talked about is these products are easy to use, right? And where are the interfaces evolving towards now? So if you look at Siri, Alexa, and voice-based products, interfaces in voice are going to become more and more natural because they are the most natural interface. I'm speaking to you, right? So voice is the most natural interface between people, and we want to make voice the natural interface between people and products also. So imagine you are talking to your, your car. Let's say you bought a Tesla car. All you have to say is take me home, and it should just do it. Today the interface is you have a key, you have a gear, you have a steering, you have a clutch, you have a brake. These are interfaces today. Suddenly they have all vanished, and now there is only one interface, voice-based command, the car will take you. Isn't this amazing what technology can do? Reimagine commute, for example, right? Now, why are interfaces important for Indian context? This our students have to really understand that we are not just building products for the urban, English-speaking, tech-savvy population. We are going to need to build products for the rest of Bharat, right? People in our villages, in tier 2, tier 3 towns, where they don't understand English, they are not tech savvy, and they can only speak to their apps, and they cannot speak English. So we need to build products in 22 Indian languages. That is the new norm for a new product in India. So Google Maps will not work if it doesn't work in all languages. It just nobody will use it, right? So that is how product thinking has to come. We have to bring principles of inclusivity and say how we don't build just for us, but for everybody. And interface has to become very simple, speech first, and in all languages, and maybe multimodal, right? Photographs and all that. Now, these are the two I's. What is the third I? Is this enough? Or we need one more I to make a good product today, right? So that is the intelligence part of it, right? So if I look at this is the MVP, the minimum viable product today must scale at a planet level, must have very easy interface, and must become intelligent over time. That means it has to have the ability to become intelligent over time. That is what a key product is. So what did Google search taught us is that you don't have to launch the best search engine on day one, but you have to put enough feedback loop to continuously improve the search engine over the next 20 years with a lot of feedback data. So today Google search is getting 8 billion queries a day, and people are clicking on it. They are liking the result, not liking the first result, clicking on the third result all the time. Google is learning from that feedback. So Google has not mastered the search engine per se. It has mastered the art of collecting feedback and continuously improving the search engine. And this is the new mindset we have to teach our students, that it is different. IT is different. AI is very different in that sense, right? The next I is instantaneous. Today we want our Blinkits to deliver in 7 minutes, our pizza to come in 30 minutes, our Netflix to play immediately wherever we are. So we are in the world of instantaneous decision. Instantaneous. So for example, banking, let me give an example. So back in the day when we were taking loans in the banks, we will submit the paper, more papers, and it will take bank a month to make a decision to give loan or not. Today, what is happening? There are hundreds of companies who look at your SMS data, who build a credit model of each person based on their SMS data, which says reminder, thank you for payment, late payment. Based on that, it is able to tell whether a person is good with money or not. And then they can give instantaneous loans, right? Have you heard of instant loan? Banks are calling you and saying you are pre-approved for a loan. You see where the world has gone from 1 month after applying a loan to pre-approved loans. So everywhere the world is moving towards real-time decision making, right? And the last part that we'll talk about, which is missing today, is what I call an integrated product, where the sensors and decisions are all integrated into it. So the modern enterprise is not able to AIfy themselves because integration mindset is missing. Intelligence is there, but integration is missing. So we'll spend the rest of the time thinking about what does that mean. Yeah. All right. So let me skip this. Let me now talk about how the products are evolving. So if you think about the physical products, they came with what we call programmed intelligence, right? If petrol is less than a threshold, turn the lamp on, right? Something. Then came the second generation products, where these were purely digital products. And we learned the art of what we call crowdsource intelligence. Because humanity is using these products and giving feedback, these products are becoming better over time. This is the art we have learned in the last 20 years, how to continuously improve the products. Where are we going next? In the next 20 years, what are we going to build? Any thoughts? Let me pause here and see what you guys think. How are the idea of products evolving? ChatGPT is already a product 2.0. What is product 3.0 going to look like? Any thoughts? No? So we are already living those products. We don't think of them as products. So for me, a smart city, one city is one product, right? So now India has so many cities. These are the products. Look at the state of our cities. If we think of them differently, if we AIfy them, suddenly they'll become smart cities, right? So these are what I call ecosystems as products. So smart city is a product. The entire telecom network is a product, not a SIM or a phone or a cell tower. I'm talking about the whole telecom network is a product. The whole refinery is a product. We are not talking about one cracker here and one boiler there. We're talking about the entire unit as a single product. Similarly, in agriculture, we are not talking about one drone as a product or a fertilizer as a product or a tractor as a product. We're talking about the whole agriculture ecosystem as a product, right? Similarly, healthcare ecosystem as a product. See what happened during COVID, right? We didn't know where the vaccines are, where the beds are, and slowly we figured it out and made it like a system. So you can take vaccine anywhere, you can go to any hospital, and it became a seamless system later, right? Because we're not dealing with hospital as a product now, we're dealing with healthcare as a product, right? And e-commerce is a great example. So these are all what we call complex systems. These are the products for which we have to train our students to say, how will your IT thinking and your AI thinking evolve if you want to build such complex products, right? So what I mean by that is all industry verticals. If I look at retail, telecom, banking, finance, hospitality, food delivery, pharma, manufacturing, these are all industry verticals. They are already complex systems. They are the products of the future. They are not looking like a product, but they are the products of the future, right? Similarly, all business functions like finance, HR, infrastructure, marketing, sales, these are also products of the future, right? The whole ecosystems, agriculture, tax, in the social sector, our intelligence community, the defense department, airline industry, properties, the whole property thing, the payments, the UPI, for example, energy. These are all important infrastructures for the country. They are also products. So hopefully you understood the level at which we are thinking now. We are not thinking of each component as a product. We are thinking of the whole domain as a single product, right? So there's one healthcare product in the world. Everybody is using it. It is an integrated healthcare system, right? So that is a product. So this is the new thing that we want to talk about. Now, what makes these complex ecosystems, right? So if I look at, for example, telecom, the it's not made up of one type of entity. It is made up of many types of entities, right? There are billions of customers, millions of towers, antennas, sectors, grids, SIM cards. So there are lots of entities that make up a complex system. There are a lot of interactions that are happening. If I look at retail and just pause what Amazon is doing right now, I will see that some people are searching for a product, some people are making a payment, some people are delivering, some people are changing the pricing, some people are creating ads and sending ads to us, right? So all these are different types of interaction. It's not a simple interaction that you'll give me a prompt and I'll give you a response. It's a single interaction system. See how simple ChatGPT is compared to these products, right? It has its own complexity, but what we are talking about is a different kind of complexity, right? Data complexity. If I look at the electronic health record of every patient in the country, ideally where it should be in the next 5 years, it will contain your blood sample reports from all the past, all your X-rays, MRI scans, all your gene sequence data, all the time series data, your ECG and Fitbit. See how one person's record will contain all types of data. So this is called data complexity. Then you will have metric complexity. So if I'm building a YouTube and I'm measuring the recommendation engine metric, or if I'm building Gmail and measuring the spam metric, these two metrics are independent of each other. So these are simple systems. What is a complex system? Your operational metrics, right? How you allocate cabs, how you do pricing, your operational metrics will affect your customer experience, which will affect your business metrics. Therefore, it's a complex system where multiple metrics are there and they affect each other in a very complex way. It becomes a complex system. Yeah. Then you have decision complexity. You're not making one decision. Given a prompt, what should be a response? You are making hundreds of decisions in any of these complex systems, right? So like in retail, you're making a decision about what results to show this person given a query. Who should deliver this packet to that customer from which warehouse, right? These are all decisions. And what is a business at the end of the day is a collection of decisions. What does AI do at the end of the day? Continuously improves these decisions so that the organization becomes more effective, products become more effective, more efficient, lower cost, and scale, right? And finally, we'll talk about workflow complexity. So it's not made up of one type of workflow. What is a workflow? So for example, if I say somebody ordered a product on Amazon, there is a workflow that gets triggered, right? Where to deliver from, how to pack it, who will deliver, OTP, payment. So there's a workflow aside. Like that, there are hundreds of workflows running in every domain. So we need to develop in our students a workflow mindset, right? So I'll show you what that means and all that. So a complex ecosystem is made up of all these things. We'll only focus on systems and workflows, right? So let me skip this part. This is not relevant to us. So this part I talk about it to the CIOs of the company. And so let me just skip this part. So now let's talk about how to tame the complex system. We just saw what is a complex system, right? We saw examples of a complex system, and we know that we are not ready to deal with that kind of complexity. So how do we now break down a complex system into two parts, systems and workflows, right? So this is the system thinking in AI. Now, let's take an example of airline industry, right? Now, what are the systems in the airline industry? I'm not talking about Indigo Airlines. I'm talking about airline industry, right? So there is one system for booking your tickets. There is one system for entering the airport. There is one system for handling your baggage. There is one system for maintaining the aircraft. There's one system to deliver food to your aircrafts, right? So we have multiple systems. There is one system to train the pilot who is going to pilot the plane. So there are 5-6 different systems which are needed to put together airline as an ecosystem, right? So we understand this terminology and we understand what are systems. Systems are well-defined things that do what they do well, and multiple such systems are needed to run a complex ecosystem, right? Same thing is true in our universities. We have a separate department for admissions. We have a separate department for academic excellence. We have a separate department for R&D. We have a separate department for maintaining the lawns and a separate department for upkeeping the university infrastructure, a separate department for IT, a separate department for recruitment and all that, right? So these are the systems within a complex ecosystem, right? And then what are the workflows? So what is the workflow in case of airline industry? A workflow is a passenger. Every passenger uses all the systems to finish the job, from booking a flight to exiting the airport and taking the flight and all that. He touches all the systems to get the job done. So think of workflows as the horizontal things that happen, and systems are the vertical systems that are available. And what is a workflow in a university setting? Every student is a workflow for us, right? We have admission on one side, we have recruitment on one side, education in the middle, safety and all of that included, right? So we understand how to tame a complex system into vertical systems and horizontal workflow. So now let's talk about systems. So what are the different systems in an ecosystem? So the first system is a system of sensors, right? Every time we collect data, it's a system of sensors. So sensors are sensors, right? COVID test, blood test, X-ray, MRI, these are also sensors. But transactions are also sensors. So if you think about, let's say you make a phone call on a telecom network, a record gets created somewhere, right? If you book a Ola Uber, a transaction record gets created somewhere. If you watch a movie on Netflix, a record gets created somewhere. So not only our sensors are sensors, but our applications are also sensors, right? A payment application or a entertainment application or an education application, they're all sensors too, because they are also collecting data. So this idea of what is sensor thinking has to evolve, because that is the beginning of AI thinking. Then we have system of records. This is what, we store our long-term, short-term memory, right? So like humans have 5 systems of sensors, right? The 5 senses. Then we have long-term, short-term memory, right? We store things, we remember things. So what all do we remember? We remember the static knowledge, right? What are the location of all the cell towers of Geo in this city is static knowledge. Then we have dynamic knowledge, right? Every transaction, every phone call record is stored. So that is dynamic knowledge, right? Then we have content. Then we have features we create. Oh, this customer likes veg food. This customer likes blue shirts. So we have features. They are also stored somewhere. Then we have inferences. Every time we run an AI model on a customer and create a score, we have a score.
Sir, sorry for disturbing you. Hello. Sir,
yeah,
sorry for disturbing you. But actually, we have scheduled the examination of all the participants at 6:30.
Oh, really?
So we need to, yes, sir, yes. Sir.
I thought this
So we
session
need
was
to
7:30.
conclude. Okay, sir, not an issue. We'll share these questions of all the participants.
Sorry, what do we do?
Is it okay? Sir, we need to conclude today's session here. I'm extremely apologize for it, as the exam is scheduled today at 6:30.
Okay, then carry on.
Thank you.
We can set up later. Yeah, please, all the best for your exam.
Thank you so much, sir. Thank you, sir. Now, all the participants, please log on to your AICT ATAL portal, and you will get the examination link. So all the best to all the participants. If you are facing some attendance issue, don't worry. We will mark your attendance within the 3 working days. And even if it's incorrectly marked by us, then kindly know us after the 3 working days. But please appear in the exam